My name is George. I work as a lead consultant for Redify. And this is going to be a quick introduction to F#. So I wonder, for how many of you this is going to be the first time you see F# code? Cool. Okay. In that case, the pace might be a bit fast because we will see quite a few of features, but the idea of this presentation is that you get a feeling of what is F# and what type of things you could do using the language. So F# is actually an open source language. Microsoft is one of the supporters of the language. It's cross-platform and it's functional first. By functional first, we mean that it's actually a multi-paradigm language, so it is imperative and functional. But the language is designed in such a way that will force you to write functional or to think to use the functional mindset first. And it's very good for writing simple code that will solve complex problems. So if you think about C# and F# and you try to compare them, you could say that C# is an imperative language that has quite a lot of functional features, like link being one of the best, while F# is a functional language that has quite a lot of imperative features. So you could potentially solve any of the problems that we solve every day with any of these two languages. It's just that maybe if you want to approach the problem using a functional mindset, F# might be better suited. So as a convention, I will use these blue boxes for C# code and the purple ones. So yeah, it looks a bit weird there.
Blue one?
Yeah, for F#. So if you get a bit lost and you don't know what you are looking at, just maybe pay attention to the box and that might help you. So one of the toughest part of learning F# is that you need to actually learn two things. One is a new way of programming for us that we are used to imperative programming, and this is functional programming. And the other thing that you need to learn is actually a new syntax that is quite different from what we use in C#. So this talk is not really about introducing functional programming, because that might be like a whole big topic, but it is worth mentioning that these two concepts that you see in the screen are maybe the most core concepts that you find in functional programming, and some of the features that you will see in the next slides are related to these two concepts. The first one is the declarative style, and by that we mean that instead of telling the computer what to do step by step, we actually ask what we want instead. And it would be the same difference if you go to a bar and you ask for a ham and cheese sandwich, or you ask the cook to take 2 pieces of bread, put ham and cheese in the middle and some butter. This second way of asking for things is going to be imperative. So to translate this to code, if you will have a for each loop that will have an if condition inside and will filter some items, adding these items to another collection, or you decide to use a where method that LINQ provides, that's a big difference between being imperative and declarative. The second concept there is immutability, and you will see what I mean in the next slide. So the code that you see there looks similar to the var that we have in C#. Actually, if you use the var keyword instead and you put the semicolon next to that, it's the same. But there is a big difference there, and the main difference between these two is that the F# one is actually immutable. And by immutable, we mean that once you set 1 to x, you cannot change x anymore. So if you want to do something like that, it's not going to work. And if you think about functional programming, has its roots in mathematics. And that expression that you see here doesn't make any sense from the mathematical point of view, because there is no value for x, so x is equals to x plus 1. So if you want to achieve something like that, you will have to find a new name for that expression, and that could be y. And that's valid functional code. But we said at the beginning that F# is multi-paradigm. So if F# would be a pure functional language, you had to deal with that without having an ability of having variables in the same way that you had in C#. But because it's a multi-paradigm language, it allows you to actually have mutable values that are the same as the variables that we have in C#. And in order to use them, you need to use the mutable keyword, so you really feel the pain that you shouldn't be doing that. And also, you need to use the left arrow symbol there to be explicit about the fact that you are pushing values into that member. So let's talk about functions, because functional programming is basically programming with functions. And to be really picky about that, we don't have functions in C# as they are usually used in functional programming. But the most similar thing that we have are methods. Because in C# everything is an object, methods are functions inside objects. And here we have a method that takes 2 arguments and sum them. And the same kind of code, but in F# will look like this. And let's analyze what we see there. The first thing that we notice is that we use the same let keyword that we used before. And the reason for that is that in F# functions are treated as values as well. So we use exactly the same keyword for defining values and functions. The next thing next to the let keyword is the name of the function, and we use lowercase in F# for defining functions. And next to that, you see the 2 parameters that function is receiving. We don't use parentheses, and we don't use comma to separate the arguments. We just use the spaces. Another thing to notice is that we haven't defined any types there. So you don't see integers in that piece of code. And the reason for that is not that F# is a dynamic language, it's a strongly typed language like C# is, but it has a very powerful type inference system that will infer the types for you. So in this case, it's going to infer that you are trying to use integers there. But whenever you need, you could be explicit and define which are the types that you want to use. Everything that comes after the equals is going to be the body of the function, and because F# is white space significant, that means that by aligning the code, that's enough to define the scope. If you think about in C#, we do both things. We put curly braces and we also align the code. Well, that's not needed in F#, as it is also not needed in many other languages. And the last thing there is the return. We don't use the return keyword in F# because every single line in a function in F# is going to be an expression, and the last expression that gets executed inside the function is what we are going to return. In this case, the result. So you could simplify that function in C# because you don't need the intermediate state, just return the sum of those 2 elements, and you could do the same in F#. That's the same code. And whenever you have just one line of code function in F#, you could write it in this way. So it's just one line of code. If you think about how would you express that method in an interface, so what is the type of that method, you could say that is like it is there. And in F#, the definition or the signature of that function is going to look like this, in which you have as a first argument of type integer, the second argument of type integer, and the last thing that you see there is actually what the function is returning. And if you want to pass this method around as an argument of another method in C#, you would have to define this type. Yeah, so then you could pass sum as an argument. And here the first 2 types are the input parameters, and the last one is the output or what the function is returning. In F#, the type of this function looks like this, in which you have 3 integers, and remember the first 2 are the input ones, and the last one is the output of the return of the function. So, tuples. We have tuples in C# as well. They are not immutable like they are in F#, and they are not as nice as they are in F#, but they are there, and you would use tuples whenever you need to return more than one value from a method. So if you want to return more than one value, the options are you create your own type, you return an output parameter for that extra value, or you use a tuple. To return a tuple in F#, you will do it in this way. So what we do is to have parentheses there and separate that with comma, and that actually tells F# that this is a tuple. But the best part is how you consume a tuple, because in C# you will have to access the item 1 and item 2, while in F# you actually could assign the result of that function to two different values, and the compiler will decompose that for you and put the first parameter of that tuple in the first value there and the second one in the second one. And this even works with output parameters. So if you are consuming a method from let's say the VCL, and that is returning an output parameter, the F# compiler will convert that to a tuple, so you could actually get the success and the value both in the same line. So tuples are good, and we use them a lot in functional programming, but sometimes you need to be more explicit about the fields, because otherwise with a tuple you need to know what field is in which order, and that might work inside some scope, but if you want to expose this to someone else, you want to be more explicit. And whenever you want to do that in C#, you actually define your own class, yes? And maybe the class would look like this. But we said at the beginning that functional programming is also about being immutable, and that class is not really immutable. So how do you make a class immutable in C#? Well, you need to use read-only fields and then set those read-only fields in the constructor. You could argue that you could achieve a similar result by having private setters, but that's not true, because any method inside that class could modify that state. And when you are immutable, you want to be sure that nobody will change that state. So to define something like that, similar to that in F#, you could use a record type that will look like this, and that record type will have these two fields inside. So how do you use record types? Well, having that one, you just create them using the curly braces and set the two fields there. And something to notice here is that I haven't defined in that line of code that the type of this record is division result. So again, the type inference system is recognizing, given the amount, the fields that I am using, that this is a type that I can use. And you might think that this looks like the object initializer that we have in C#, but this is not actually true, because if you miss one of those fields, the compiler will complain about that. So this is more like the constructor that we had there that has all the parameters because they are read-only. Well, that looks the same as this. So how do you change a record type? Well, because it's immutable, you cannot change it. What you could do is to create a new record type and now set new values in this new record type. So in this example, I am keeping the same quotient, but I am setting the reminder to 0, and this is a new instance of that record type. And because this operation is so common in F#, we have the with keyword that will be doing actually that. So if this would be a record type that has 5 members, it's going to be quite handy to use a with keyword by only specifying the ones that changed.
Sorry, I don't understand. It's the separate type save. There's no actual type there. Where's the type in F#?
Yeah, so what happens here is that the compiler, when I am using this line here, is trying to find which types I have defined that actually has these 2 members. And whenever it finds this one, it's going to automatically use that one. So if you want, you could be explicit about, and you could, at the end of this expression, be explicit about, okay, I want to use this one. But for most of the times, you don't really need to do it. The compiler will infer that for you.
So does the compiler instantiate the type?
No, so the compiler, if you go to Visual Studio, and here you could see an example in which this is the record type, and you could see here, I don't know, maybe I could zoom. You could see here that my record is actually type my record. So the compiler actually is reading this code and recognize that this, although I haven't been explicit about the type, is inferring that type for me. So it's similar to when we use var in C#. You know that you don't really need to be explicit about that, because if you are calling, let's say, a method that already returns that type, the compiler will infer that for you. But this is much more powerful because it's not just in line like it happens with the var. So
George, can you declare, say for example, take a type division result and type division result 2 with the same Yes.
Yeah, you could do that, and in that case, you might want to be explicit about that. But I had the same concern when I started using this, and let me tell you that because you actually need to define all the types, all the fields when constructing this, it's very rare that you will have exactly two types that will have exactly the same fields inside. So most of the time it's quite useful. But as I said, you could be explicit about that and just...
And in fact, if you have a record that has the same typed fields, they are actually the same type.
Yeah.
So what you want to call that type depends on your usage of the thing, and you can explicitly mention it.
Yeah, that's
This
a very
type
good
collision,
point.
By the way, the principle behind this is because the compiler is doing so much work for you, you want to make as many failures happen in compile time as possible. So if the compiler detects that there's an overloaded type, it'll actually prevent you from compiling the program.
Yeah, that's a good point. So now the next thing that I wanted to mention is the pipelining operator. And here we have two lines of code that actually are using two functions. The first one is promote to VIP that receives a customer and returns a promoted customer. And the second one is increase credit that receives the promoted customer that we got from the previous line and returns an upgraded customer. So you could rewrite this code in this way, just by changing the order and putting customer now before promote customer. Promote to VIP. So what the compiler will do in this case is going to send that whatever is on the left side of the pipeline operator as the last parameter of that function. And therefore what that allows you is, if you think about, in this case, whatever we got as a return of this expression is going to be the input of the next expression. We could rewrite this code in this way. So now the customer is going to be sent to promote to VIP, and the result of this is going to be sent to increase credit. And you could reformat this code in this way, and this is much more clear and declarative, because now you could see that the customer is actually going through this list of steps. Another concept that might be related to that is the partial application. Here we have a function that has two parameters and adds them up. You could call this function with 1 and 2, and then you will get 3. But what would happen if you call this function with only one of the parameters? In C#, you will get a compiler exception, a compiler error here, because one of the parameters is missing. In F#, if you do that, what you get as a result is another function that actually still specs that second argument. And once you pass that second argument, it's going to give you the result. So instead of calling this result, I could call it at 1, because it's actually adding 1 to whatever is still waiting for. And then I could call add 1 in the future and pass in the second argument, and then that will return the final result. Another related to that is the composition, in which you have this function, these two functions that are, the first one is adding 1 and the second one is adding 2. And by having these two, I could compose them together, and now I could create an add 3 that will actually execute both things. And I could call add 3 and get the number 4 here. Okay, options. So could you tell me, by looking at that signature, that's a C# code, what is going to happen if I pass an ID that is invalid? So there is no customer for that given ID. Is this code going to throw an exception? Is going to return a customer that is null? You cannot really tell from that code. You need to actually go, if you have the code, you go access the code. If you don't have it, you decompiler whatever you need to do, or you guess. Yes, if you guess, and most of us will guess, and that's where we make mistakes, because we will assume that that won't be null, and at some point we will get a null reference exception. So Or the other solution is to put if everywhere and check for nulls everywhere. Now if we change that and we ask for the age of the ID, for the age of the customer given the ID, now we have an integer. What is going to happen there? Well, we have exactly the same problem. We won't get any nulls, but we have exactly the same problem because we don't know what is going to happen. We will receive like a -1 if that's the case. Well, luckily for us, in C#2, the nullable primitive types were introduced, and now we could be explicit about that. And the first thought was like, oh, we will get nulls also now when using primitive types. But the best thing of this is that now we have an option. We could be explicit to really say if this could be null or not. So if you think about when you use nullable types, you don't use them everywhere. You just use them whenever you are sure that null is a possibility. So the caller now gets the hint that this could be null and therefore needs to handle that null case. But whenever you are sure this will never be a null, you will return integer. You will never go for, by default, using the nullable integer. So in C# we have integers, we have nullable integers, and we have like a customer, but we don't have nullable customers. What we have is we use exactly the same type for both null options and not null options. So in F# we have integer, we have an option of an integer, we have a customer, and we have an option of a customer. So if you have F# code that is returning just a customer, that is never going to be null. If you are returning something that could be null, then you need to be explicit, and that should be an option of a customer, and therefore you know that you will need to handle that case. So how do you use this? Okay, let's assume this is add1, and now add1 could receive an option of an integer and not longer just an integer. So we could check if the x is none, and none would be the equivalent to null in C#. And if that's the case, we will return 0 because we don't want to add anything to that. And if that's not none, that means that it's some, and therefore we could get a value from that and add 1 to that. Or we could use something that is called pattern matching that will actually match this value x with any of these two patterns. The first one is none, and if that's the case, we will return 0. The second one is some, and if that's the case, by putting some and then the letter n or any letter here, the compiler will put here the number that was inside that object, and therefore we could use it in this side. So we are adding 1 to whatever we got there. And this is one of the last ones about discriminated unions. So let's think about the case in which you need to return more than one result. So in the case of the division, let's say that instead of throwing an exception when you try to divide by 0, you actually want to return two different types. So in C# you would write something like this, or you could use an interface. Just one would be the success, the other one would be the error. In F# to handle this type of scenarios, you could create something that is called discriminated union, and this is actually a union of these two types. So division result is going to be the equivalent to the base class, and then you have the division success that is going to have these two fields, quotient and reminder, and the division error will only have this field that is a message. So yeah, we will see an example of that during the demo, but that's basically the idea. You could return one or the other one. And this, I believe, is the last one, is units of measure. And here we have two figures. One is the distance in meters, and the other one is the distance in kilometers. And here we are doing some operation with those that doesn't make much sense, because it doesn't make sense to add up meters and kilometers. But the compiler doesn't know what you are doing there. It's just both are a float number, so it will allow you to do that. And it will give you a result that is going to be wrong from the business point of view. So to solve this type of problems in F# we have something that is called unit of measure, and you could define these types that are decorated with attributes called measure, and this is the way that you define attributes or use attributes in F#. And then you could attach those types to those figures. So now you are explicit that this is not just a float number, you are talking about meters, and this is another one in which you are talking about kilometers. So if you try to do something like that now, the compiler will complain about that, saying that you cannot operate with these 2 units of measure. And this was inspired by a NASA project that failed at some point because there were 2 teams working in isolation, and one made the assumption that was 1 unit of measure was going to be used, and the other one made the assumption that another unit of measure was going to be used, and in the end the calculations were wrong. So let's go and see a quick demo of these things. So this is just a project, an F# project, and you could go and create it by new project. You go to other languages, Visual F#, and then here you could create like a library if you want, a console application. And you have also this one that is a tutorial that will show you quite a lot of code that you could run and get familiar with. You have also here the F# Interactive, that is a console that in which you could write code here. So I could say let a equals 1, and then you use 2 semicolons to actually execute that, and you see then the result of that. So I could do things like 1 plus 2, and I will get 3, or I could do a plus 2, oops, and I will get 3 as well. So you also could take things from here and send them to the F# Interactive by pressing Alt-Enter. So now this code was executed, and this was the result. So now I could take this function and send it there, and you see there the signature of the function. As we said before, these are the two arguments, and this is what we return. And we could write this, if you want, in a second line like this, and I could even, I don't know, assign this to I don't know, set. And now if I decide here to return this, because this is the last expression of the function, what you will see is that now the type has changed. Now this function is returning a string, and I haven't changed the type here, or I haven't been explicit about the type. It's just that the compiler inferred that because the last expression that got executed is a string, it is actually changing the type of this function. So I could execute this function in this way and get the result 3. Here we have a tuple that has 2 values there, so it's composed by an integer and a string, and you see here both values there. And I could decompose the tuple by assigning that to 2 different values here, and you see now that the number has the number 42 and the message has the string hello. Here we define a record type with these 2 fields there, and you could create a record type, as we said before, without having to be explicit about the record type, and it will recognize that it's my record. If I want to be explicit about that, I could say my record, and that will actually be the same, but I don't need to. And here I'm creating a new instance of that record, but I am changing the message from hello to hi. Here we have 2 functions, at 1 and at 2. Both just receive 1 integer and return 1 integer. And then I could change the order. I could call 1 to add 1, and then I could use the same result and call add 2, or I could put everything together like this, and I will get the same result, because this is actually sending the value 1 to add 1, and then the result to add 2, and then I will get the result there. The next one is partial application. So we already had sum 1. So sum has this signature, so expects 2 arguments and returns the last one. But now I decided to call it with just 1 argument, And the result of this is another function that expects that last argument. So I could come here and say add 1 and pass the other argument, and I will get the result. I have a 2 here, and then I could decide to compose them. And now add 3 expects 1 item, and it will add 3 to that. So I will get 4 as a result. Options, we have here add 1, that is optional. So because of the fact that I am trying to match X with these two patterns, yes, so I am saying, okay, match X with these two patterns, the compiler automatically is inferring, okay, so this is going to be an option type, it's not going to be an integer, it's going to be an option of an integer. So automatically what was that here? If you see, this is actually telling me this is going to be an integer option. So I am actually checking for none. In that case I will return 0, otherwise I will add 1. So I could, and here you could see that in the signature I get that the first argument is an option. So now I could call this with none and I will get 0, or I could call this with sum of 1, and this is interesting. We do use parentheses in F#, but we use them the same way that we used to do it in mathematics. You know, if you have more than one argument, because we use spaces to separate arguments, if I remove the parentheses from here, F# will think, the compiler will think, that I am trying to pass two arguments, sum and 1. So I need to be explicit about this and say, okay, no, this is just one argument. So I could wrap it in parentheses. And I could, if I then need to pass another one, I could also wrap it in parentheses here and put it here in the middle.
Or you could pipeline.
Yeah, or you could pipeline. So if I call it this with sum 1, what I am getting is the number 2, because actually this is adding 1 to anything that I pass inside sum. The discriminated union, here we have the two values that I showed you before, division success and division error, and then here I am using them, so the divide now will match the divisor, that is this second argument here, against the value 0. I keep highlighting, but it doesn't look good. So if the divisor, and this pattern matching is similar to the switch case that we have in C#, but it's much more powerful. Here you are just seeing one of the simplest cases, but you could do a lot of stuff with this. It's matching the divisor with 0, and if that's the case, we are returning this type. And we use this underscore for anything else. So we don't care if anything else but 0, we could potentially do the division. So I will return as a division success in the quotient, the actual division, and then I will calculate the remainder. So I could execute this, and I will get this divide. So if I set the divide, I don't know, 10 by 2, this is going to give me a division success with these two values inside. And if I do divide 10 by 0, now what I get is a division error that will show me this message that we have here. And the last thing is the unit of measure that I want to show you. We could define these two units of measure, and now I am tagging those figures in this way. So this is actually now a float. The type of this is a float of m, and this one is a float of km. And now if I try to do this, you already see that the compiler is telling me that there is something wrong, but I could try and I will get the same error here. And it's saying that the unit of measure km doesn't match the unit of measure m. So in that way you save the trouble of trying to compute two different units of measures.
Can
Can you give an example of how that match thing would be more powerful rather than C#?
Yeah. Okay. So let's say one example
Given the
is,
sum and none, I would say is more powerful. I think you have a bit.
yeah.
Just that, I would say it's more powerful.
Yeah. So let's say this guy is receiving a tuple. Yes. That tuple will have so this x will be a tuple, and you want to match this against two different patterns. Let's say this tuple starts with x, or it has no x, sorry, s, like anything that is there, and the number 10 after that, or let's say anything else, just for the sake of the argument. So now what you are doing here, you are telling the compiler that this is actually a tuple. Let me zoom it. So yeah, so this is actually a tuple, and this star means that it's a tuple. What we have here is we are asking the compiler automatically to decompose this, so it will match any tuple that has as a second argument 10, but we don't really care about what is the first argument, and we actually want that in the s variable, so I could come here and use that, and this is actually will have whatever was in the first one. You could use this also with record types, and you could define here, I don't know, field 1, oops, equals, and then you define s, and then field 2, and you set your record type there, and it will match that. And you could go even further. There are things that are called active patterns, in which you could create your own types that are going to be used to match another types. And also you have you could use partial active patterns. That's also even more advanced. But to keep it simple as well, you could say, you could put on top of the pattern matching here, you could put let me put it back, none, or sum of n. You could use a when condition here and say when n is measure of 10, or is more than 10. So this is going to match not only that you have that this is an option that is of type sum that has a number here, but also for the branch that n is more than 10. So it's very powerful, and you end up working a lot with pattern matching.
Is the order important? Like if I put less condition that is general in front of the specific condition, it will fire.
It's going to. That's a very good point. So it's going to be applied in that order, and that raises another point that I didn't mention. That is that the compiler will complain if you didn't handle all the possible scenarios. So, and that's a very interesting thing, because that's not something that happens in C#. But let's say you have like a discriminated union, like the one that we saw before, this one, and then what happens is that you will go, and in every case that you will use this division result. Now, if you use pattern matching, you need to pattern match both cases. But then you decided to add a third case there, and now the compiler will tell you in all the single places where you were using this, because now you need to add a case for that third case. So it could be a bit annoying as well, but it's actually the F# really tries to force consistency and correctness. So that's the idea.
Although if you use the underscore, it will match with that. So.
Yeah. So in the end, you could always say that by putting an underscore at the end, but at least you are being explicit about that case.
Thanks.
Yep.
So I just wouldn't mind seeing more object-oriented type code.
Yeah.
It's more procedural, the type of code you're trying to write. I mean, I know you've got some types there, but I mean, we're used to doing object.properties
Yeah.
as bread and butter, so it's kind of seems like you need to do that, or not? You don't have to do that at all.
Yeah. So, yeah, that's a good point. So F# is actually full compatible with .NET. Yes, and the same kind of code that you write in C#, you could write it with F#. It's just that to get used to this new mindset of functional programming, that is not new. Maybe it's new for most of us, but not. It has been there forever. What happens is that it's good to go to the basics of functions and what you could do. But languages like Scala really try to embrace both paradigms, and because you could argue that the main discussion would be in between imperative and functional. And object-oriented programming so far has been using the imperative approach, but nothing stops you from using object-oriented programming using a functional mindset, and that's what Scala is trying to accomplish. Just to give you an example, the string that you use in C# is the best example in which you are mixing object-oriented and functional. Because if you think about every time you call methods like replace, you are not actually changing that object. Another object is returned with that change. And this is actually very functional. So you could potentially create objects in which you could put methods and still keep those objects immutable.
But we knew at Christmas and we had to write code that was like, all the parameters of your arguments had to be, called explicitly. That would be just, a disaster.
Yeah.
So you need object-oriented.
Yeah, and you could write object-oriented code. Just to show you an example that maybe it's not really showing much about object-oriented, but this is an interface in C# and in implementation. If you want to write, you could write exactly the same in F#. It will look a bit different, but the code that I will show you here is maybe a bit more powerful. What we are doing here is actually defining an object. This is object-oriented programming that is implementing that interface on the fly. So you haven't had to define that object. How many times you had to explicitly define an object because you want to implement iDisposable, just for that single scope of that method? Well, this is something that you could use in F#. And things like the default constructors that in the end they are not going to be, or the primary constructors are not going to be part of C#, things like that are actually things that you have in F#. I could show you. I have.
For how long?
Huh?
How long has it
In
been?
F#, I don't know, forever, 5 years. Things like, so many things from F# comes to C#. But just to give you a very quick look of what you could do from the object-oriented point of view, let me just show you classes. So this is a class in C# with immutable. This is a class in F#. A class, an object-oriented class that has one property, that is that. And you don't even, this is a primary constructor, and automatically F# will create a field for you behind the scenes, and you define member and the name of the property, and you set that to that field, and we'll do the same as this code. If you want to have mutable properties, this is the way that this will look. Again, mutable properties is something that you want to avoid. Every time you want to go for the imperative type of mindset, you will need to fight the language a bit more, and C# is going to be easier, and the same is through the other way around. If you want to go for immutability and functional in F#, in C#, you will need to fight the language. Public methods, this is the way that you define a public method in F#, just by defining the name of the method, the parameter, and then the body. In comparison with this, you don't need to define the constructor there. Private methods are just functions. So all the things that we saw so far, this function is just could be used as a private method inside a class. This class doesn't have any parameters as the constructor. So there you have the default constructor. Inheritance, you could have an abstract class in that way. And you see there. That's another way. You need to override, and you need to be explicit about inheritance here. And this is a point to be clear about, because in C# we have these two ways of inheriting. When you implement two interfaces in C#, you could use implicit or explicit implementation. So you could use the name of the interface, dot, and the name of the method to declare that. Well, in F# you don't have the implicit option. You need to always to be explicit. And in this case, we have the interface, and then we are explicit about that this class is implementing this interface, and this is the method actually that we are implementing. And if you would be implementing another interface as well, then you will need to put another section of code that will say with, interface, and the other name of the interface, and then with, and implementing that second interface. Any other questions? Yeah.
Just a comment, really. I mean, F# is actually based on ML, which has actually been around for very many years. It's not a. It wasn't invented at, Microsoft by Don Simon. ML has actually been a research language, much the same as many of the, much like Haskell and so on. And ML was all built based on type inference. So a lot of the stuff that F# has is actually bringing all of the type inference and the strength of strong typing to the Microsoft ecosystem.
Yeah, and then after ML, it came. Well, there were many, but OCaml was the one that was trying to mix object-oriented programming with ML. And actually, F# is taking that idea from OCaml and taking that over, because it actually brings the functional programming language to the .NET community. And also, that's the other thing around. So brings the .NET ecosystem to the functional programming community as well.
And Link, for example,
Link?
Yeah, you must be on better on steroids.
Yeah. So the thing is that most of the functions that you have in Link, Link is, to be honest, Link is very functional in C#. If you tell me what is the best thing that C# has in regards to functional programming, it's Link. And Eric Meyer said that every single method that you have in Link came from functional programming and from Haskell. So I could show you how it would look something like.
I would say like the pipeline operator. That's all you need. Like once
Yeah,
you have functions that float by themselves, you don't need extension methods because you could just pipeline to that function.
So I don't know if we have enough time, but I could cover that quickly. But maybe
we can just make Hattie shorter.
Yeah. So then, let me find. I have here a list here. So here you have a comparison. So here, this is Link, and this is using lambda expressions, and this is how it looks the same in F#. So the first thing to notice here is that these are functions, and they are grouped in modules. So what you will call a where condition or a where method in C# is actually called filter in F#, and it's actually called filter everywhere else but C#. In C# they try to make it similar to SQL, but if you go to any other functional language, this is going to be filter and map, and not where and select. And then you have here a lambda expression, and yes, lambda expressions are a bit more verbose in F# because you need to define the fun keyword first. Well, in C# you don't need to do that. But the best part is what he said, is that you are using a pipeline operator. And what that means is that if you think about where is this? What is the extension method doing for you? If you have this filter, yes, function, a method in C# that receives a list and receives a condition, yes, and now you change that and you make it an extension method and you put this and inside an static class. What this guy is doing for you is that now, instead of writing this in this way, in which you need to pass the list here and to pass the lambda expression there, now you write this in a totally different way, because now suddenly numbers become the object that holds that method. Yeah, so you say numbers.filter. Yeah, that's what linked is. But this is a lie, and that's a good lie, but what the compiler is doing actually for you is to take whatever you wrote here and put it there, because this is the first argument of that method. This is still there. It's just that it's syntactic sugar that you are now putting that on the left side. Yeah, on the left side. So now, but that allows you to write code in this way, because now, because the main object, the main parameter is on the left side, you could chain codes there. And this is what extension methods are really, and they are very nice because it gives you that syntax. Well, if you use the pipelining operator, you get the same benefit, but you don't need to define extension methods. This works for any function. So this guy is actually sending, instead of sending this as the first argument of the function, is sending this as the last argument of the function. So now you get the same thing. Is like if you would be able to use extension methods for any method that you had in C#.
I reckon the main benefit is that Intellisense because you've got the context on the left-hand side,
yeah,
be presented with options.
Yeah,
on the right-hand side.
That's one of the main arguments in favor of object-oriented programming. That when you write object-oriented code, you tend to write you use the main argument as the first thing that you write. So then you write dot or whatever, and then you will get the list of possible things that you could do. Yeah, that's true.
I have two questions, if I may.
Yeah.
Units of measurement, when they conflict, you get an error. Can you define conversions between units?
Yeah. So you don't define conversions, but so before going there, something that you could do with unit of measure is just operate with them. I said you cannot add them up because it doesn't make sense, but you could potentially divide, and you will get a new unit of measure. Now that could be kilometers per hour. And you could also multiply them, and you will get square meters. And from this point on, this is actually square meters, and you cannot use meters. You always need to use square meters. But as the same way, if you want to convert that, what you need to actually do is, let's say this is a function that we convert one to the other one. So forget about this part. The first thing that you need to do is to take that and divide it by one unit of the same type. By doing that, what you do is to remove, maybe it's better if I show the code. So here I have this thing that if I execute this, I will get this that is a float of m. If I decide to divide that by 1m, what this is going to give me is the same figure without unit of measure. See, this was float of m, and now it's just float. So by dividing by the same unit of measure, I actually remove the flag. So now I could multiply this by 1,000, and let's say kilometers. Yeah, divide. Thank you. So if I do something like this, sorry, this needs to be a float. So now I would actually get the same value, but now expressed in kilometers. So most of the time you would actually multiply that, and I think it's going to be something like this. Yeah, float kilometer. Because if you try to divide, the compiler is going to find the wrong type. So you multiply by whatever. This is actually one extra zero. It's going to be that one. Yeah. And the other question?
Part 2. Can you go to the definition of the sum function?
This one.
So I think that shows that the types as all being ints, but
Yeah.
really that should be applicable to anything that implements addition.
Yeah, that's a good point. So, and that's a restriction that we have in .NET, because there is no way, there is no type that you could use for that is a super type of integers and floats. For example, Haskell, or float or any number that could be added. Haskell doesn't have that problem. So in this case, because of the majority of the cases, is that you will need integers. The compiler is assuming the default, But as I said, if you, for example, if I try to add this to a float automatically, that's giving the compiler the hint that needs to say, okay, so this is going to be a float. So even in the same file, if I decide to consume this, but given two floats, now this is going to tell that it's a float. Although in the definition, I didn't give him any hint. The usage of this is actually telling the compiler about that. This works only if you use it in the same file. If you go to yeah. So, but if you are trying to do something else here that is actually not adding up, it's something more complex, and you have different types that could operate with that, the compiler will generalize the code for you. So the way that you use generics is using the apostrophe. In F#, we saw an example recently, but I didn't want to explain that. But it will generalize that for you. So whenever you have a super type that could apply to that, you could use that. Yeah.
For what types of tasks would I use F# versus C#?
Any. No.
Something more practical.
Yeah.
Business type tasks. I would prefer one to the other.
Well, I did a rules engine with it.
Yeah.
Yeah, but I only
So.
the client changed it. Yeah.
So to be honest, there is a big overlap in between these two languages, and most of the things that we do every day, you could do it in with any language that you want. I would prefer to do it in F# because I like the way that F# works, and I like how succinct is the code. But if you ask me to really be picky, I would say that calculations are very good, is where you will see F# shining. So, but whenever you think, if you think about, and this is more about functional programming and imperative programming, maybe discussion, and not F# and C#, but whenever you need to execute code in parallel, and that nowadays is more often every day because even phones now have multiple cores, and today might be fun if you write an application that runs in a single thread, but in a few years that's never going to be true. So it's not going to be true. You will need to, now we will need to start taking advantage of multiple cores. And whenever you use object-oriented in the imperative, with the imperative mindset, what happens is that you share state. So now different methods are modifying the same state. And you could parallelize that, but you need to be careful, and the effort that you need to put into trying to parallelize that is quite big. When you start writing code using the functional mindset, what happens is that you are forced to use immutable types, and therefore you cannot change anything. And you need to start thinking, okay, how in the hell I am going to handle this change? Well, I need to create a new type and pass this new type to another function that will take care of this. So you write the code in such a way that is much easier to parallelize. It might be hard to see it at the beginning when you are so used to write imperative code, but when you start seeing the different pattern, it might help in the future. And that's one of the main reasons why languages like Scala or Clojure are getting a lot of popularity lately, because this is what is happening. They realize that with imperative programming, there is a barrier or a roof that we will hit soon.
What about dynamic types? I mean, you don't need it F#.
Yeah, in functional programming, really you want to be strongly typed most of the time, but there is a module to add dynamic to F# if you need to. So I think that's enough. We will cut. So Hadi could.
Actually, when he said he was not giving a general answer. He did mean that. Like he tried to convert so many things to F#, and so far he has been successful with most of them.
Actually, I would go beyond calculations. The whole async monad and the ability to compose async tasks in F# just makes writing async code so much easier.
We got like 95% of the way through a functional programming talk before someone had to say monad.
Yeah. Is there something you would not recommend C# F#?
Writing XML.
Yeah. So that's in fact the only way I would write XML. And these type providers. Exactly that.
So
that's the only thing I would use.
I would say that if you are doing something that really requires a lot of changes, Yeah, it's very mutable, you would say. Maybe you could do it with F#, but again, you will fight the language a bit. So it's up to you if you want to take that approach or not. But for some tasks, maybe imperative programming is still the best option. And in those cases, I wouldn't use F#, or I would use it. But it's up to you how many of those scenarios you have in your application and how many of the other ones, and which is the language that maybe is the best tool for you. Something to mention is that the tooling with F# is not as nice as the one that we have in C#. So if you are picky about the tooling and the experience and having a big team with a lot of people, maybe F# is going to be hard to introduce. So I would start by writing some libraries or some specific code with F# and then see how that goes. But for sure, yeah, I think most of the problems that we need to solve every day you could solve them with F# as well. So I am giving a workshop because you could learn all of this or trying to learn by just listening, but unless you write code, it's going to be impossible. So the next step would be to try to write code and to practice all those features and to really feel how it is like to write F# code. So I am giving a workshop that is for free next week. That is going to be in Microsoft. I think there are a few seats that are still available there. But if you don't want to go, all the material for the workshop is in that website, F# Workshop. You could download the exercises and try that yourself at home. Something else to mention, with Troy, we organized the F# user group in Sydney. So the next meeting is next week, and he's going to give a workshop about functional programming. So if you want to come along, you are more than welcome. Also, Troy is planning to start a podcast about F#. So if you want to follow what is happening there, that's the Twitter handle and the website. And the last thing to mention is that Don Syme, that is actually the creator of F#, and he's Aussie, he works in Microsoft Research in the UK, is coming to Sydney on the 6th of January, and he is going to present at the F# user group. So maybe you need to learn F# now, so then when he comes, you already know. And here you have some resources that might be useful for learning. I will put this online so you will be able to get it. And that's pretty much all. Thank you.